Welcome to another interesting mathematics class. My name is Eke Omoji. I'm your mathematics friend and tutor. In this lesson, we'll be talking about quadratic equations. But before I go into what quadratic equations are, I would like you to understand where quadratic equations are applied in real life. You might be wondering how jet fighters are able to get their targets. Well, the mechanism behind getting these targets is done most times using quadratic equations. And the calculations may look complicated, but they are as simple as what we see in this class. There are so many other examples, but just understand that quadratic equation is applicable in so many places. It's applicable in sports, like how a player could kick a ball. It's applicable in warfare. It's applicable in so many other places, like your normal dart game. So as we go down, you understand how quadratic works. Well, before I go on, I would like to give you the lesson objectives for today. We shall be discussing how to solve problems involving factorization of quadratic expressions and equations using common factor method. Also, we'll be seeing how to solve quadratic equations of the form AB equal to 0, where A or B is equal to 0. Before we go deep into discussing what quadratic equation is, let's first of all understand what an equation is. So if you're asked, what's an equation? What will be your response? An equation is any mathematical expression that has a quality sign in it. A quality sign, that's all. With that, an expression can be converted to an equation. So, if it has no equality sign, it is only an expression and not an equation. There are different types of equations, so we'll discuss just a few of them before we concentrate on what we really want to talk about. The first type of equation we'll talk about is called linear equation. As you can see on the board, linear equation can be given as the example you have, 2x equal to 4. If you look at that, you'll see that we have 4. We know the value of 4. And we will call this 4 our constant in this case. While we will call these 2 coefficient of x. And then x itself, we will call the unknown. Or we'll call it the variable. So you either call that x the unknown, or you call it the variable. Next time when I start talking about the unknown, please note that it is simply the variable which we do not know the value yet. Okay, so from there we can now say that our unknown is x. And the highest degree of that unknown is 1. So how did we get that 1 as the power of the unknown or the variable? Let's look at it. 2x equal to 4 is the same thing as saying 2x raised to the power of 1 is equal to 4. That 1 is invisible, but it's always there. With that, we can say that the power of the unknown, which is the variable here, is 1. The second equation we'll be looking at is called quadratic equation. An example of it is 2n raised to the power 2 plus 5n minus 7 is equal to 6. If you look at that, just as we did before, we have 2 which we know as a coefficient of n squared. We also have 5 which we know as a coefficient of n. We have minus 7 which we will call constant. If you look at this equation, you see that we know the value of 2, the value of 5, the value of minus 7, and that of 6. But we do not know the value of n. Because we do not know the value of n, we will say that n is our unknown or the variable. So our unknown in this case is n. If you also look at it carefully, you will see that the highest power there is 2, when we have 2n raised to the power 2. So because the highest power of the unknown or the variable is 2, we would say that the highest degree of the unknown is 2. So a quadratic equation has the highest degree of the unknown to be equal to 2. The next we'll be looking at is cubic equation. An example of cubic equation is u raised to the power 3 minus 5u raised to the power of 2 plus 3u minus 6 is equal to 0. If you look at that equation, you will see that we can tell the value of every other term. For instance, we know that in front of this u cube, we have 1, though it's invisible. We also know that in front of u squared, we have minus 5. We know that in front of u, we have 3. And then we also have minus 6. But we do not know what u is. Because we do not know what u is, we call it the unknown or simply the variable. Remember I said that u is called the unknown because we do not know its value yet. If you look at that equation, you would also see that the highest power of u is 3. Because the highest power of u is 3, we then say that the highest power of the unknown is 3. The next we'll be looking at is the quadratic equation. And in quadratic equation, the highest degree of the unknown is 4. You may see in different books that from quadratic equation down, they all may be given a simple name, polynomials. We are not going to talk about that now, but just know if you see it, it simply means from any power above 2, you can term all of them as polynomials. Now that we know what an equation is, let's now talk about what a quadratic equation is. Remember I said earlier, a quadratic equation is simply an equation which has the highest power of the unknown or the variable to be 2. That's a simple definition. But you could have names like quadra, which indicates that it is raised to the power of 2, as you can see on the board. Don't bother yourself. All you need to understand is a quadratic equation is simply an equation that has the highest power of the unknown to be equal to 2. Like I said earlier, quadratic equation is applied in so many places. With the diagram you see on the board, it is a diagram of a ball being kicked. When that ball is kicked, it follows a quadratic path. And understand this, quadratic equations, they simply create a nice parabolic path. Parabol, well, there's no big grammar there. You can see the curve on the board. We call that a parabolic path. Just that curve. So, why do we solve quadratic equations? Remember, nothing is done without a reason. The reason why we solve quadratic equations is to get their roots. Or we simply say to get the factors of that equation. We now know why we solve quadratic equations, right? But how do we solve it? The way to solve quadratic equations are actually 4. There are 4 ways to solve it. The first method is called the factorization method. The second method is called the completing the square method. The third is referred to as the quadratic formula. The quadratic formula is also known as the almighty formula. Finally, we can also solve quadratic equations using the graphical method. In this part, we shall be concentrating on solving quadratic equations using factorization method and specifically the common factor method of factorization. When asked to solve a quadratic equation and you are told to factor or to factorize the equation, that means you should apply the factorization method. And in applying the factorization method, we will need to know the 2 ways of applying it. There are basically 2 ways of applying the factorization method. The first method is called common factor method, and the second is called analytical method. In the common factor method, this requires us to find either a common letter or to find a common number. For example, looking at the board, you see that we have 3x squared minus x. This expression has x in common. There is x here and there is x here. So it has x in common. For the second one, we have a common number, 2x squared minus 2. This expression has 2 on both terms. There is 2 here as a coefficient of x squared, and also there is 2 here as a constant. So it has a common factor of 2. In analytical method, we are expected to find the common factors, which could be alphabetical or numerical. But in this case, we are also expected to get the direct solutions. For example, 3x plus 2 and 2x minus 3 are factors of 6x squared plus 5x minus 6. Therefore, this and this are the factors of 6x squared plus 5x minus 6. Now let's concentrate on the common factor method. How do we find the common factors? Let's look at these 2 circles and find what is common in both of them. By looking closely, we could see that the numbers 2 and 4 this here, 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 and here, are common to both circles. So we would say that they are common numbers. Also, we could see that the letters A, H, P, and X are common to both circles. So now, what is a factor and how do we find them? A factor of a number is simply a number that divides that number without a remainder. How do we find these factors? Well, let's take a simple example. What are the numbers that can divide 100 without a remainder? Let's start with 1. Can 1 divide 100 without a remainder? Yes. If you divide 100 by 1, you get 100, right? So we can say that 1 is a factor of 100. Also, let's try 2. If you divide 100 by 2, we'll get 50, right? Also, we can now say that 50 is a factor of 100. Also, 2 is a factor of 100. That is because 2 times 50 will give us 100. Let us try 4. 100 divided by 4 will give us 25. So if we say 4 times 25, we'll get 100. That means 4 and 25 are both factors of 100. Let us try 5. Also, 100 divided by 5 is 20. And 20 multiplied by 5 is 100. That therefore means that 5 and 20 are both factors of 100. Wait, did you notice that I skipped 3 while I was going down? Let's try 3. 100 divided by 3, what do you get? Well, I got 33.33. That actually means that 3 is not a factor of 100 because when you divide 100 by 3, you get a remainder. So you see, to find the factors, we simply look for a number that divides that other given number without a remainder. There are 2 rules you need to have in mind while trying to find factors of any number. The first rule is that every number or alphabet is a factor of itself. Also, the number 1 is a factor of every number or alphabet. Now that we've discussed how to find a common factor, let us now apply it to solve a few problems. We'll be using the common factor method to solve the 2 examples on the board. Example number 1, what are the factors of 4x squared minus 2x equal to 0? Example 2, we'll be factorizing 2x squared times y squared plus xy squared equal to 0. So now let's solve example 1. Let's start with the first step. We are going to check to see if there's a common factor between A and B. Wait, what is my A and what's my B here? Oh, okay, just look at it. This is my A and this is my B. The A in this case will be regarded as the coefficient of x squared, while my B will be regarded as the coefficient of x. Let's see how we can solve this. If you look carefully, you will see that 4 can be divided by 2, right? And when you do that, you get 2. Also, 2 itself can be divided by 2, and that will give us 1, right? If that's true, it means we can say that 2 is a common factor of 4 as well as 2 itself, right? Remember one of the rules, that every number is a factor of itself. We just applied that now. Let's go to step 2. We'll rewrite the equation by bringing out that factor we just found, which is 2. We'll rewrite the equation as shown in equation 1. Please take note. The reason why it's written like this is because if we decide to expand back this bracket, we'll get the initial equation. This is what I mean. This is our initial equation we have in equation 1. If we decide to expand it and we say 2 times 2, we'll get 4. And the x remains there, x squared. We also say 2 times x would get minus 2x. This was our original equation. So you see, by expansion, we'll get back the original equation. That means our equation 1 is true. Okay, notice that we have in the bracket 2x squared and x. Both of them have x in common. So we can find the common letter between them as x. This is what I mean. 2x squared minus x both have x, right? I can actually rewrite this equation as 2 times x minus x. So you can see that they both have x in common. If I bring out that x they have in common, I can rewrite this equation as shown in equation 2, which is now 2x, open a bracket and write 2x minus 1, close the bracket, and that is equal to 0. This is our equation 2. Please take note, this was simply obtained by bringing out the x from equation 1. Our step 3 will now be to write the factors. In this step, we can write the factors of equation 2 as 2x equal to 0 and 2x minus 1 equal to 0 as well. Let's name the first one equation 3 and the second one equation 4. So we can say that 2x equal to 0 and 2x minus 1 equal to 0 are the roots of 4x squared minus 2x equal to 0. Let's move on to step 4. Now, let's get the solutions by solving for x. Please take note, in this step, you could simply say, make x subject. Now, by making x subject, we would say that 2x equal to 0 would imply the same thing as saying, divide both sides by 2. If we do that, if we divide the left-hand side by 2 and the right-hand side by 2, we would have these 2 cancel out, and then we'll now have x is equal to 0 over 2. Recall from your basic mathematics that when you divide 0 by any number or multiply 0 with any number, the answer remains 0. Therefore, 0 divided by 2 here would give us the answer 0. Let's also try the other one. Now we can also see that 2x minus 1 is equal to 0. This also implies that by adding 1 to both sides, that means that 2x minus 1 plus 1 is equal to 0 plus 1. By doing this, we eliminate 1 from the left hand side. That is because minus 1 plus 1 is equal to 0. Therefore, we now have 2x is equal to 1. At this stage, all we need to do is to make x the subject. If we make x subject by dividing both sides by 2, that is 2x over 2 is equal to 1 over 2. The 2 here will be cancelled by the 2 here. Remember, the one up is called the numerator and the one down is called the denominator. So they will cancel out and we'll now have x is equal to 1 over 2. This will be the fraction form of the answer. If you like, you can go further to put it in decimal form, which will be the same thing as 0.5. We now have our solutions as x equal to 0 or x equal to 0.5. Having solved the first example, I believe we can now comfortably try another one. Am I correct? Okay, let's try example 2 and see how far we understand this method now. In example 2, we're asked to factorize 2x squared times y squared plus x times y squared, and that's equal to 0. Step 1, let's check for a common letter in all the terms. Remember I said this and this are considered the terms. So I can call this my first term and the other one my second term. So let's check to see if there's a common letter in all the terms. If you look at your first term, you will see that there is x. Also look at the second term, there's also x. But the x in the first term has a power of 2, so it's x squared. While that on the second term has a power of 1. Remember I said earlier that there's an invisible 1 there. So by expanding this on the first term, we have 2 times x times x times y plus x times y is equal to 0. Looking at that, you can now see that there are 2 x's in the first term and 1 in the second term. Also, there are 2 y's in the first term and also 2 in the second term. By bringing out these terms, we can now say that we have x in both terms, also have y squared in both terms, and now what we are left with in the first term is 2x, and then what we are left with in the second term will now be plus 1, and this is equal to 0. Please take note, the reason why this equation has reduced to this form is because if we multiply what is inside this bracket by what is outside, we'll still get the original equation. We tried that before. You can try that out. It will give you the same thing. Now, our next step is to rewrite the equation as x times y squared is equal to 0. Let's name that equation 1. And also, we have that 2x minus 1 is equal to 0. That we will call equation 2. Notice that in this case, we do not have a common number. Rather, what we would have is a common letter. Our step 3 will now be to solve the equations obtained in equations 1 and 2. By making x subject, we have the following. X y squared is equal to 0. Therefore, x equal to 0 divided by y squared. Remember, whenever 0 is divided by any number or any alphabet, the answer is always 0. Therefore, x equal to 0 divided by y squared is equal to 0. That will now be our equation 3. Also, 2x plus 1 is equal to 0. Therefore, x equal to minus 1 over 2. Or we can say that x is equal to minus 0.5 in decimal form. And that will now be our equation 4. Now, our solutions are x equal to 0 or x equal to minus 0.5. Now, let's go on in this class to solve one more example. Remember, in our lesson objectives, we said we'll be solving quadratic equations of the form a times b is equal to 0, where a or b is equal to 0. Example 1. What is the solution of the equation 2x equal to 0? Note that in this equation, 2 is not equal to 0. Therefore, 2x equal to 0 can only be defined or valid or true if x is equal to 0. That means by making x subject, we would have that x is equal to 0 divided by 2. That implies that x will be equal to 0. Please don't forget, whenever you divide 0 by any number, the answer must remain as 0. So we now have that x is equal to 0. Having solved those examples, we have now come to the end of this class. However, before we leave, let's take a summary of the things we've done. First of all, we learned that quadratic functions are obtainable in several sectors, such as in sports, warfare, business, engineering, and so on. We also learned that quadratics can be solved using factorization, completing the square, almighty formula, and graphs. We also learned that there are two methods of factorizing quadratic equations, which are common factor method and analytical method. We also learned that in common factor methods, factors of either numbers or letters that are common to all terms are grouped together. And lastly, we learned that the roots of the equation are then found by solving for the unknown variable. Now, let's go on to try some test questions. Let's see how far you can do now. Question number 1. Which of the following below is not a quadratic equation? Is it A? Is it B? What about C? Or is it D? Well, the answer is C. Question number 2. Which of these options is the correct set of solutions of the equation 3x squared minus 6x equal to 0? Option A, x equal to 0 and x equal to minus 2. Option B, x equal to 1 and x equal to minus 2. Option C, x equal to 3 and x equal to 0. Option D, x equal to 0 and x equal to 2. The answer is option D. Thank you for your time, and I hope to see you in the part 2 of this topic. Happy learning. Bye-bye.